Hi, now let's continue our lecture on diagnostic tests, where this diagnostic test will be cover the multicollinearity problem in multiple regression model. The diagnostic test is important in order to get the best estimated model. Right? Okay. In introduction, in general, multicollinearity refers to a situation in which two or more explanatory variables in a multiple regression model are highly linearly related. We have perfect multicollinearity if, for example, as in equation above, the correlation between two independent variables is equal to 1 or negative 1. So you can just refer to the econometric model for the equation. The multicollinearity problem is closely linked to the seventh OLS or ordinary least square assumption that cannot be certified like xi, the observation of I, where I equal to 1, 2, 3 observations are linearly independently. The problem is when x2 and x3 is linearly dependent. In other words, if you get value of x2, then automatically will get the value of x3 and vice versa is true. For example, if x2 is 2x3, and if x3 is 3, so x2 will be 6. This means x3 is twice than x2. In other words, there has been a multicollinearity problem in the estimated model between x2 and x3. The impact of OLS estimator from expectation value. It's still unbiased. Example, expectation of BI equal to beta I, where I equal to 1, 2, 3. If such sample is big enough, hence still can get the real value as expectation value. But the expectation value for beta hat and variant of beta hat still very big. The equation is how to do the test in order to confirm the situation. The answer is t-test will help you on this issue. Recall the 4th step of hypothesis testing. When we do the hypothesis testing, the conclusion will be the tendency to accept actual. In other words, beta 2 equal to 0 or not significant. However, actually, because of the existence of multicollinearity problem, actually beta x2 is important, but when we test the hypothesis, we find out x2 is not important. In this case, we have to not accept the hypothesis even though actually the variable is actually important, but in the hypothesis we found it is not significant. So there is a contradiction in the solution during the hypothesis testing. How to detect the multicollinearity problem? As mentioned in early chapter, the multicollinearity problem can be happen in multiple regression model only. There are few methods or approach can be utilized in order to search the problem in estimated model. We have a few approach. The approach 1 is variance inflation factor or VIF analysis. Approach 1, the variance inflation factor analysis. The result can be produced through SPSS software. I believe in our previous lecture, I already told you that during the statistic criteria, I already told you to click on VIF to produce the VIF result in the SPSS output. And the result will be come out like this. So please refer to your output for the project whether you get the term of VIF in your coefficient output. Approach 2, the role of correlation. In this case, we apply the Pearson correlation. I believe in our previous study, we already done the Pearson correlation. So, to doing the approach to test, we at the beginning, we have to run the Pearson correlation. Approach 3, we compare the correlation with the R square the R square is actually from the SPSS output. This approach will have applied in the class project. According to approach 3, the correlation, Pearson correlation result will be compared with R square. We want to make sure that whether R square is large or R square less than. Okay, if R square large than the correlation between variable, and we can say that the problem is exists of multicollinearity is exists but is not serious. However, if R square is less than correlation S1 and Sj, for example S1 and S2, and the multicollinearity problem is exists and the problem is serious. Please correct this one is actually less than. Okay, let's discuss about approach 3 step-by-step procedure. By using your project data, you are required to estimate the correlation between independent variable only. Like I said here, is only independent variable S1, S2, S3, S4, no Y. You don't have to put Y to do the Pearson correlation between the independent variable only. Report the correlation result between the independent variable. Compare the correlation result between independent variable with the R square value that you gather from the SPSS output. In order to report the result, you have to use the specific table provided. Okay, this is a table that you need to use. This is how you have to present your result in your project. Report the table, you have to use this table for the project. The general regression model, and you have to report the estimated model, become equation 1 and 2. According to equation 1 and 2, therefore, the correlation Pearson result between the independent variable will be in 3 combination. Because you have x1, x2, and x3, so the correlation Pearson will also in 3 combination. Correlation between S1 and S2, correlation between X1 and S3, and correlation between S2 and S3. The correlation result can be put here, and here you have to provide the space for you to put the sign, and the R square should put here. Okay, let's go discuss the correlation S1 and S2 with the R square. We found that the correlation is 0.7522 is less than 0.9950. Therefore, because of correlation S1 and S2 is less than R square, where the 0.7522 is less than 0.9950, and there exists multicollinearity problem in the estimated model, but the problem is not serious. Let's talk about the second example. Correlation between x1 and x2 compared with the R square result. Here, the correlation is 0.9972 is large than R square is 0.950. As a conclusion, therefore, because of correlation, x1, x2 is large than R square, where 0.9972 is large than 0.9950, and there exists multicollinearity problem in the estimated model, and the problem is serious. Thank you so much. I hope that you can just repeat the video and try to understand how to perform the analysis. As a conclusion, to perform the multicollinearity process or test, firstly, you have to do the Pearson correlation between the independent variable only, and you also must have the regression model of overall result, and you must do the table, presentation table like this to report the result. Okay, so I repeat again. Firstly, you must estimate the Pearson correlation between the independent variable only. In this case is 1, S2, and S3. Then you have to produce the regression result of overall model. Then you have to produce the table like this and give the conclusion as given here. This is how to read the result, by comparing the value produced from the multiple regression and also from the correlation Pearson. Alright, thank you very much. Goodbye.